Huh? What are you doing? Oh, you're kissing Dad's leg? Okay. Well, gentlemen, we're out here to look at Mr. J's 1x4 original DaveMade. He said he bought this new from the DaveMade camp back in 1999. First off, I want to say thanks for all you do. My request list is upgrade with all you can do to it, please. The box is a 1999 built DaveMade, and I'm the only owner. It still performs great, but I want you to touch done to it. I guess it would be okay. Thanks again, Mr. J. Talking with him on the phone just a few minutes ago. He's like, man, that's an OG DaveMade. And I don't argue with him. There's a small fact, though, that I can't believe. Number one, the hardware for the fans is not rusted. But the hardware for the cabinets is rusted. I don't know what it was about the 1990s, but the quote, stainless steel screws, I don't think these are stainless steel, by the way, but the stainless steel hardware, man, you breathe on it wrong, rust. So, rusted on the inside. We're gonna change all the hardware out and make it stainless steel, is the long and the story of it. We're gonna flip the fan over so it's pushing cold air in and then across the heatsink versus sucking hot air or cold air in, heating it up, and then letting it percolate across the components. I mean, really. Let's see here. At some point or another, this has seen just a little bit too much drive. That's the only thing that's even remotely close to being damaged in here. The variable moves so smooth. American-made variable, back when we could get them cheaply and they're not $35 and $40 a piece. Let's see, all American-made ferrite back in here back in the day because we could still make things in this country. This does have the typical, yeah, DaveMade design. This solder joint here going down the side, which supports things, it's got a crack in it. Of course, we're going to do a little slight power wire upgrade here to the beads. And we're going to replace his wire here. The wires that came in this originally are long since gone. His friend, he said, I had a friend go in there and replace them because they were just horribly small and too short. And it's like, yeah, I've dated girls like that. He just laughed. I laughed too. That and the solder work there is just top shelf. But it's worked. It's worked for all these years. So we're just going to clean it up a little bit. He wants me to check out the coax connectors, and if they need to be replaced, they're going to be. And we're going to replace this relay with probably a 10 ampere, probably a really nice Japanese one that will last forever and ever and ever and ever. Okay, caution. Nerd moment incoming here. So, we have this thing called air pressure and how much impedance it costs to either push air volume into an environment or pull a vacuum upon it. And well, your impedance ratio rises as you have more stuff in the way for the air to flow through, right? So the idea is that if you have a vented or slotted opening that sits between you and the outside world, that is resistance to the airflow. Okay? And if you have components that also stand in the way of the airflow, you're going to have a rise in impedance pressure, if I'm not mistaken. Now, I could be wrong. I mean, I'm just looking at this as, I know we got an increased volume if you take a CFM meter and you push the air into the cabinet versus pulling the air through it. And also my logic's always been, why not let, because let's face it, the total amount of surface area inside this enclosure that's going to be able to transfer heat to the air media itself is relatively minimal, okay, compared to the heat sink, which is vast. There's a whole lot more surface area to that with the heat being directly impinged upon it, and then you have the aluminum, which is an awesome conductor of heat to the atmosphere. It doesn't sink it quite as well as copper, but it's a really good transfer media. Anyhow, that's why we use aluminum and blah, 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 blah. Me personally, I don't like to pull the air through the cabinet, which is a high level of impedance, resistance. As soon as we're applying resistance to it, as soon as it comes through the grill, then more resistance is we're forcing it to go across the heatsink, and then even more resistance if we're trying to make it bend a 90-degree turn and then come out through the fan. Me personally, I like to blow the cool, unadulterated air into the space, the working space, myself. It's just me. Push cool air in, let it hit all the components, make a nice gradual 90-degree turn, and then run into the high impedance of leaving the cabinet. That's just me personally. Call me crazy, but that's how I feel about it. So, in fancy terms, that just simply means that DaveMade.
Look at that! Wow! It's working!
Come on, Schwartz. Come on, Schwartz.
Helmet, what's going on? Sanders, what's going on? It's DaveMade. She's gone from suck to blow.
I could be wrong. I could be delusional and disconnected. That's the way I like to think about it. I like to cool the components with the coolest air that I can, and I personally feel there's a little bit of less resistance if we push or pressurize an enclosure versus pulling a vacuum upon it. Just saying. Like I said, could be wrong. Wrong every day. Leave your comments down in the doobly-doo. Okay, so let me put the headphones way away. I'm on the phone here. But I'm done with this, so I gotta shoot a segment on it, right? So what we have done is we went through and we put brand new coax connectors on this thing for him, because they were all slopped out like a Tijuana hooker. And then we went and put all new hardware, top, bottom, top and bottom. Everything's got brand new stainless steel hardware on it. Down here inside the cabinet, we just did a very modest. We took and put a piece of 14 gauge over here to upgrade the power wire for the driver's section, over here in the corner. We upgraded to 12 gauge over here, feeding from our distribution bar. We put brand new 8 gauge in it with nice, about 3 foot-ish worth of length power wire on the back. So then we went through and we reflowed all the solder joints all the way around that support the board, because they're notorious for cracking. We went back here and we blocked off the remaining bits of the vent with that little tiny little phenolic that I like to use. We put a brand new Japanese 10 amp relay in here and got rid of the 5 amp relay. Brand new key-in transistor, even though those never really wear out. We replaced this 100 ohm resistor, which is notorious for burning up. What causes this is when we move the knob here at the front of the amp, the power's got to go someplace, right? So they put this little resistor here offset, shunted to ground. Well, we replaced it with a 5 watt. I didn't want to get too far from the original DaveMade mix, Mojo, you know what I mean? Because this box has worked great since 1999. I just went in and refined it just a little bit. Played with the input tune just a scooch. as in like I changed the capacitor by like about 5 puff. And the end result is this. So we're on right now about 12 volts, 12.5, 12.8 over here. This is a 1,000 watt slug in this meter, 1,000 watt slug in peak, 1,000 in average, 5 watt slug in reverse back from the bird, 10,000 watt dummy load. So we're going to use the bench 2950 as our driver radio. Okay, so we're seeing maybe 15, 18 watts. About 6, 7 bird. We're going to start our dead key out at, we'll do 1 watt carrier, okay? So let's turn that back in reverse. Let's turn the amp on. Audio, about 700 peak, about 300 bird on 12 volts, which is pretty good for 12 volts. I mean, that's actually really, really, really good. We're gonna go ahead and turn the amp off. And now let's translate up here. Let's see, 2950, this one here. So 5 watt slug between the 2950 radio and this 1x4. Audio. That's our pass-through tune. Let's turn the amp on. Audio. That's our input tune. Audio. Okay, so now we got our baseline set up. So let's go down here, or turn on the power supply. And we're going to wait for a couple minutes. We're going to wait for this, or just a couple seconds. We're going to wait for this to charge up and get up to about 15 volts. We have the power supply set at 15.2. So after everything makes it through all the connectors and down through and into the amp, we're about at 14, 15 volts, 14 and a half. So let's zoom back in for those of you that are watching this on a phone. Same drive, audio. So now we're up to 425 bird, and we're hitting the 1200 watt stop peg. So we figured out over the years, in a couple thousand YouTube videos, that when we hit the stop peg, we're actually at about 1200 watts. Audio. Our 1 watt dead key isn't getting us much as far as a base carrier. We'll turn that up a little bit. So to get a 100 watt carrier on this amplifier under volts, at 15 volts, we're putting just shy of 2 watts into it. Gets us 100 watt out. So we're not showing you all swing. Audio.
This is the
Audio. Buried off the scale, 1200 watts. All right, so now we're going to go up to 2x. Right here, between the 40 and the 60s, the 1,000 watt mark. So 12, 14, 16, 18, and 2,000. We're going to end up being really close to that 12, 1,300 watt mark. Audio. Audio. 1,200 watts. 400 bird on this radio. Now I want to try a different radio. We're not going to change anything else other than we're going to hook up to the D-Rail Cobra 29 that I got sitting over here. I don't get to use this radio very often because a lot of the stuff I work on is not low drive like this box. So we're going to take it to the max. We'll take and we'll put this down in 1x, and we're going to turn the amplifier off. So let's grab the microphone for the D-Rail radio. Let's zoom in here. Audio. Same 20 watts worth of drive. But now look at our average meter. Remember, 400 watts is what we were getting out of it average before. Audio. Audio. So now we're getting 600 bird out of it just by changing the radio. So I'll consider that to be a win, in my opinion. The only thing I have left that I need to do because I got to put a sticker on the front of this thing, which is no big deal. But over here I have to pick up the lid, and we have to put it, reattach it, and make sure it's all working and none of the fan blades are hitting the guard. Because remember, we took it from suck to blow. Let's test that. Well, that's it. MegaMade's gone from suck to blow. Now pulling air in instead of blowing it out. So it's just sucking air in and cool air on the components, shooting out the back. Oh yeah, good stuff. So on that note, we're going to call this a win. Gentlemen, I appreciate everybody tuning in and following along. Big shout out to my Patreons, by the way. Thank God for those people, by the way. If you ever learned anything from this channel, seen anything that you thought was interesting, or wanted to come show any kind of support, don't hesitate to come join us. It's a lot of stuff goes on over there that nobody else gets to see. Big shout out to Penta, XS, Siglant, McMahon, Bird, Coaxial Dynamics, and last but not least, I mean this from the bottom of my heart. I thank you guys. See, what is this? This is RO number 14, out the door and ready to go home. Gentlemen, I'll see you. Click, click.